This is our rock, paper, scissors. Here's the power on self-test to make sure every LED functions. Bottom row is player, top row is computer. It starts with the rightmost, and that is a win for the player, and that is a tie. If we keep playing, we'll see that is a win for the player, and that is the light display for a victory. A button press resets it. It allows you to see how much you won or lost by. See, and that's a victory for the computer. And it resets every time. It keeps track of how many rounds you've played.
Our circuit has one key design using a voltage divider. The voltage comes in and passes over one more resistor per button. So by reading that voltage, we know what button is pressed. So the first button passes over 1, the second button passes over 2, and so on. And then they're grounded so that the pin reading doesn't fluctuate wildly. Rather than focus on all the code, which just goes on and on, I'm going to focus on a few key points. In the setup, we have the LEDs put into arrays, making it easier to use later on. Rather than having to write the code twice, once for each team, I only have to write it once and then pass variables to the array for the specific team and the specific LED. There's also another array for setup that allows me to set up all the output pins in one for loop rather than 6 different lines. Another key part is the button sensing and sensing the raw values of the input pin, which is 0 to 1023. Through trial and error, found out the range for each button press and stored them as constants so I could use English in the code later on rather than trying to remember what all these numbers meant. The functions, a lot of them use inputs so that I only have to write the code for one team and it works for both teams based on what is passed in. This particular one is from the part of the code that turns the numbers that the computer knows is a win or a loss and what the player played and what the computer played into English to print out in the serial monitor. And the other key part of the code is our victory conditions. And I found a mathematical way of doing it using the modulo function, this little percent sign. It returns the remainder. So subtracting the player from the computer, adding 3, and then finding the remainder divided by 3 will always result in a tie, a win, or a loss. It'll be 0 through 2, and it'll always be correct. And for example, if the player plays rock, which is a 0, and the computer plays paper, which is a 1, and that should mean the player lost. And if we go through the code, the remainder is 2, which is a loss. If we made them both 1, it would end up coming out with a 3, and a 3 with no remainder is a tie, which paper and paper would be a tie.